All right, we're going to continue talking about domain and range, and now we are going to talk about continuous graphs. So some graphs are continuous and some are not. If it's continuous, it means that there is some connection in all of your points. So this is a continuous graph. From the point to the other point, it is continuous. It's always connected. Whereas this is not continuous. These dots are separated. This is what you saw in your last example. If I asked you to write your domain, you would look at all of the x values, -4, -4, 1, 5. If I asked you to look at the range, you look at the y values, -3, -3, 1, 6. However, in this one, it is not just these 2 points. It is all of these points in between here. And I don't just mean -3 and -2 and -1 and 0. I mean -3 and -2.9 and -2.999 and -2.8, -2.87, all of the numbers, every single one in between here to here. So because there are all of those decimals in between all of those points, you cannot just write a set of points because there are infinite points in between your domain and range. That does not mean every single number in the entire world. That's not what infinite means. It means there are so many, you cannot list them all right? Because when I talk about your decimals, you could have decimals that have just one number after the decimal and 2 numbers after the decimal and 3 numbers after the decimal. You can't list all of them. But when I ask you the domain, I need to know all of the x values. And when I ask for the range, I need all of the y values. So the graph above goes from -3 to 8 for your domain. It does not include -3 since the -3 is open, but it does include the 8 since that is closed. So every single number between -3 and +8 are included in your domain. But we can't list them all. So instead, you're going to learn about several different ways to list your domain and range. And this lesson is practicing identifying all of the correct ways. You shouldn't have to write them on your own in this lesson. So, looking at our examples. Some continuous graphs do not have endpoints, which means that they don't end at all in either direction, and some have endpoints on only one end. So these graphs here end both left and right, but also up and down. They end here and here. However, this graph that has arrows. That means it's going to continue to go down. It's going to continue to go up. It's going to continue to go left. It's going to continue to go right. I just can't fit it all on this paper. Those arrows mean that they are continuing forever and ever and ever and ever. However, when I look here, this graph is continuing left and right forever. But it's only going down to here and going up forever. All right, so those are also differences. When we have a graph that has arrows on it, in either of these examples, depending on what I'm talking about, your domain or your range, but if it has arrows in the direction you're focusing on, domain is left to right and range is down to up, then that means it's going to infinity. And that is shown using this symbol. This is the infinity symbol. It is like a sideways 8. If you can't draw an infinity symbol, here's my infinity symbol. If you can't draw that, turn your paper sideways, draw an 8, and then turn your paper back normal. There's an infinity symbol. Okay? So if your graph has arrows, it goes to infinity. You're going to use your infinity symbol. If it is going right or up with arrows, so this one right here is going up, that's positive infinity. This also happens to be going to the right. That's also positive infinity. But left or down is going to be a negative infinity. Right? This graph, this one right here, it's going up. That's a positive infinity when I'm talking about your range. But when I'm talking about your domain, it's going left, so that would be going to negative infinity. You just put a negative sign in front of that infinity. So let's talk about your different types of how to write your domains and ranges. So type number 1 is a compound inequality, which you saw in Unit 3. A compound inequality is the smaller number, some inequality symbol, your variable, then another inequality symbol, the bigger number. Your domain and range can both be written like that. You just focus on domain is X, range is Y. So make sure you have a Y in the middle of your range. Your first number is the smallest number in your domain and the symbol that goes with it based on an open or closed dot for your smallest number. And the second symbol is based on an open or closed dot for the largest number, and then the last number is your largest number. The same is true for range. Just make sure you have a Y in the middle for range. If your graph goes to infinity, positive or negative, you're going to use a less than sign for that symbol, here or here, because we can never actually equal infinity. So let's look at how our example could be written for this graph, domain and range. So domain are your x's. We're going to look left to right. So when I look at this graph, the farthest left this graph goes right here. This is the farthest left. I start here and I go to the right. So the left, and I see an arrow. If I'm going left with an arrow, that's a negative infinity. If you are going to infinity, use a less than sign. X, because I'm talking about domain. And then I need to go the farthest right that this graph goes. Well, this one happens to go to another arrow. This time it's going to the right, which is a positive infinity. So less than positive infinity. Your smallest number should always be first. Your biggest number should always be last. Negative infinity is smaller than positive infinity. And infinities cannot be equal. And domain is X. Range is your bottom to your top. So when I look at this graph, the lowest is right here, this point. And remember, I'm focusing on the Y values. This point right here, the Y value is 0. I don't care that it's at -1, that's an X value. I care about the Y value. It is at 0. So I'm going to start with 0. Now you might ask yourself, I don't see an open or a closed dot. I don't know. I don't know what's there. Well, if you don't see a dot, and it's not an arrow, then it's a closed dot. Because in order to make this graph, there are an infinite amount of closed dots side by side. That's why it looks like this. So that's a less than or equal to. My range is then Y. And then I'm going to go and look at the highest point. Well, the highest, I have both of these arrows. It doesn't matter because they're both arrows. It doesn't matter which one you look at. They're both going up. They're both arrows going up. That would be a positive infinity. So we're going to use our less than infinity. So to write your domain for this graph, it's negative infinity to positive infinity. It's 0 to positive infinity for your range. Sometimes you can use single inequalities, only sometimes. This can only be used if your graph is continuing forever in one direction. Once again, X for domain and Y for range. If it's continuing right or up forever, you'd use a less than or less than or equal to, depending on if it's an open or closed dot that you're starting at. And same thing, except backwards. Less than or less than or equal to, just greater than or equal to, less than or less than or equal to if you're running left or down forever. So once again, same graph. Let's look at how this one would work. Domain. If we are continuing to the left only forever, or the right only forever. But in this graph, we are going left and right forever in both directions. So we can't. I can't write the domain in this method. So the only method so far for the domain is this way. Now the range. Our graph is going up forever, but it's not going down forever. So I can use this inequality. It's going up. So all of the y values are greater than still this point, which is still closed. So my y values have to be greater than or equal to 0. Right? Because all of these y values, I have a y value here at 1 and at 2 and at 3 and at 4. They're all greater or equal to 0. That only works if your graph is continuing in one direction. Left or right only, and then up or down only. All right, sometimes we can use the statement all real numbers. That can be used if your domain or range continues forever in both directions. All positive numbers is if your graph starts at 0 and goes to the right forever, or starts at 0 and goes up forever. Because if I'm starting at 0 and going to the right forever, I'm on all the positives. Or if I'm starting at 0 and going up forever, I'm at all the positives on my y-axis. And similar, but for all negatives, is if I'm starting at 0 and going to the left, or starting at 0 and going down. So for example, our domain. Our graph goes left and right forever. So we would use the statement all real numbers. And that's what this is saying also. It's saying negative infinity to infinity. Every number fits in between there somewhere. Every number. So all numbers. Your range starts here at 0 and goes up forever. Those are all of the positive numbers. These three things are saying the same thing. From 0 to infinity is saying that y is greater than or equal to 0. All the numbers from 0 and up. All the numbers from 0 and up. Which are all the positive numbers. Because it's greater than or equal to 0. Those are all the positives. Those are saying the same things.